Welcome aboard. Let's do some science experiments. Here we go. All right, what are we going to do? We're going to add some sodium hydroxide over here on the left. A little bit over here on the right. Oh, pretty colors today. I want to try something with the lighting here. Let's just see what happens if I push this up like this. Just to see. Boy, that's really bright. That's way too bright, huh? Yeah, let's do this. Get that back down. Here we go. Nice colors. What's going on, Mario? Hello there, fishing. Yeah, we got some nice color action going on here, I'd say. Look at that. Beautiful flow patterns. Really pretty. Add a little bit of base. Hello there, every day. Yep, adding sodium hydroxide base to both of these flasks that contain a universal indicator. Thanks there, every day. We are getting some nice colors today. Really interesting over there. Come on, Katie. Got to get your studying done. Happy Sunday, everybody. Doing a little bit of science experiments before the big game. Got a big game coming. All right, so what are we at? pH 10? We sure are. We're way up there. Let's add some acid to both of these. Get that pH to drop. Thank you there, administrator. Took me a while. My son and I were talking on the phone. Yeah, there's some kind of sports thing today. Over here in America, it's a big deal. Super Bowl Sunday. What do you think? I think the colors are looking pretty good today. I think I got the angle right. Got some green color going on for some Philadelphia Eagles fans who might want to. The pH right now, Seneth, is going to be 7. We can tell that from our pH scale here. Yep, we got a green color, which is indicating neutral. I'm going to continue to add acid. And we're going to watch the acid I'm adding is hydrochloric acid, which is the same acid that's found in your stomach. And you can see we're getting a shift to a red or an orange color. You're welcome, Seneth. How you doing, Adiaman? Good to hear you. Good to see you. So then on the left, it's like a pH of somewhere between 3 and 4, I'd say. Over there on the right, somewhere maybe around 6 or 5. We'll keep adding the hydrochloric acid, which is the same acid that's found in your stomach. Hello there, study account. Keep on. Oh, look at those gorgeous colors. Let's get a little bit of base going in over there on the right. Here we go. Excuse me, on the left. Couple drops. Couple drops. Then we'll switch them up, huh? Let's switch them up. So base on the right, acid on the left now. See what happens. That's gorgeous. Well, administrator, if you did, what do you think? Did you like them? Yep, administrator, it is the same acid I used last week. I do have some sulfuric acid I could try if you want. Not happening, sober. I'm not a synthetic chemist. I am not a synthetic chemist. I'm not the person you want to ask to do that. Thank you there, youngin. Appreciate that. Oh, that's cool. Thank you, administrator. Which one in particular did you like the best? So administrator was checking out some of my, I'm guessing my YouTube shorts. My YouTube shorts tend to be a little better. Study, I don't think you'd want to drink this stuff. That's because one of the indicator dyes is a laxative. Might ruin your afternoon, huh? Boy, we're really getting some nice, pretty colors. I'm adding acid to the one on the right now. So in case you're new to the live, let me just explain really quickly what we do. We take a little bit of universal indicator. It's also known as rainbow indicator. It displays different colors depending upon pH. So you're going to see these. Here, let me get this on so we can see this just a little bit better. It'll display these colors depending upon pH. So you can see this one over here is a pH 7, the one on the right, which is neutral. The one on the left looks like it's about pH 4 or 5. It's got an orange color, and so that's going to be acidic. Oh, that's nice, man. The fire cannon thing, huh? Or when I burn different metals. I'm from the United States, study. Here we go. Let's add a little bit of base over here on the left. Add a little bit of a base over here on the right. that should shift to more blues and violets. Slow, I am making salt. Actually, I am making salt. So the chemical reaction that is occurring in this flask when I mix the sodium hydroxide and the hydrochloric acid. Give me 1 second, I'll find it here. Here it is. Oh man, they're both violet. Here, I'll do this. I'm going to turn these off while I'm explaining this. Katie, yeah, in the United States, we use the terms alkali and base synonymously. So here I'm going to add a little bit of acid to both of these after I've turned down the stir speed. What's up, Jim Bros? I don't have any potassium permanganate. So, I don't know. I have no idea, study. Anyway, so here's the chemical reaction that's occurring. You know, I'm either adding sodium hydroxide base or hydrochloric acid. And when these two react, the H from the acid and the OH or the hydroxide from the base, they combine, make HOH, which is water. And what's left over is sodium chloride. And so when you're seeing this reaction, you're seeing me make salt water. Now, of course, it's salt water when it's neutral. So when these two have been added in perfect balance, then they've completely neutralized each other. And that's where you see the green color. In the green areas, that's where these have been perfectly balanced. If there's an excess of acid, it's going to look more red. If there's an excess of base, it'll look more blue or violet. All right. Won't happen depressed. One of the dyes in here is a laxative, and that would end my my live in about 10 minutes. What can I use this reaction for? Making salt water. Hey, thanks, Jim Bros. Have a nice evening. Okay, I'm going to go ahead and spin this one, get this one going. Let's see which one there's more of, acid or base, or if I've neutralized it. How you doing there, Slow? It looks like there's a lot more acid over there on the left, right? pH 3, excess of acid. Let's mix this one up and see what happens. That seems about enough. And over there on the right, it's neutral. I've added a perfect amount, well, you know, close enough, of acid and base that the flask on the right is neutral. How you doing there, Patriot? Thank you there, Dicey. Forgive me, I know I'm probably not saying your name correctly. All right, here we go. I'm going to make this one over here on the right. We're going to make it basic. And it goes. Just grab salt from the local grocery store. That is a lot easier, isn't it? All right, we got some base over there. I'm going to add a little bit more acid over here. Strontium hydroxide. I don't have any strontium hydroxide, nor do I have any potassium hydroxide, Adiaman. Can I dip something in it? Says study account. Sure. What am I going to dip in it? Here, I'll dip this, this medicine dropper. We'll stick it down here into the... Can you see it over there on the right? Here, it's probably easier to see it over here. Down in there. A little tough to see. Let's get the spin bar going a little better. Then maybe we can see it getting in there. And it goes. And it goes. Not even touching. Every once in a while it touches. I have D block elements. Are all salts salty? What a great question, Kim Jong. I'm guessing yes. What would happen if you added solid elements like salt or sugar? Well, Patriot, do I have any solid? You know what? Here, let's just do something with some solids. Here, I prepared this experiment for you. You guys are going to want to see this one here. I do this one on occasion. I'm going to turn this off. So while I'm preparing this experiment over on the left, you can watch, I don't know, some color changes maybe over here on the right. I'm going to go ahead and take this particular flask here. Let me get it dried off. This is the experiment where I take some fluid. Here, you just watch. We're just going to watch this fluid here in this particular bottle. All right. Let's zoom in on it. It is pretty over there, isn't it? All right, we're going to zoom in on this one over here just for a bit. Every once in a while, I'll just kind of, show you what's happening over here. But for this, let's go ahead. I'm going to add a couple drops of, let's add like a drop of blue food dye over here. One drop, is that blue? I think it is. 1 drop of blue. Watch it spread out. It's kind of pretty, isn't it? It's really quite beautiful the way that spreads through there. Can I create some gamma rays? Not in my basement. All right. And now we're going to add a drop of yellow. Boom, in goes a drop of yellow. The blue really looks nice. Yeah? Gorgeous color mixing. Yeah, and it's, of course, as the blue and the yellow mix, it makes everything green. I like this swirl over here. It's really kind of nice. Thanks, Ursula. Okay, we'll back it out. And I'm going to mix this up. How did scientists create elements? So one way they did it is by slamming together 2 smaller elements. So like the really large ones, look at that. Look at that. Come on, baby. That's just cool. That's just beautiful. Okay. So one way they do it is just by slamming together the nucleus from 2 smaller elements. And when you slam them together, they will combine and make the nucleus of a larger element. So there's no surprise there, right? When we mix together, you know, blue and yellow, you get green. However, now what I'm going to do to this flask, or I guess this bottle, is I'm going to add a white solid. The white solid I'm going to add is sodium carbonate. Where's my funnel so I don't spill it all over the place? There we go. All right, you can see up here at the top, I got the funnel. In goes the white solid. Oh, is it going to overflow? I hope not. Just enough. Okay, there's the white solid. And we're going to mix this baby up, okay? Let's see what happens when we mix this up. Hopefully I got enough of the white solid in there. Mix it up. It looks like snow in there, huh? I do, Administrator. Sodium hydroxide is the base that I've been adding to this flask over here. So, you know, when I do the color acid-base experiment, that's when I add, the base that I add. Sodium carbonate as adiamin, and the question is why? It is because it works in this particular experiment, and it's also very easy to buy. I can buy it in the laundry section of the grocery store or retail store. It comes as, I think they call it Arm & Hammer Super Washing Soda. It is not caustic soda. Caustic soda is going to be sodium hydroxide. Sodium carbonate is known as washing soda. Let's see what happens. Let's see what happens. So I've got it. Oh, baby. It's happening. It's happening. Come on now. Look at that gorgeousness. How in the world did that happen? Katie, I saved the bottles. I saved these bottles because they're cool. Look at that, huh? We got blue at the top. We got yellow at the bottom. We got green in the middle. What in the world is going on there, huh? What is happening? So to remind you of what's going on so you can kind of tell what's happening in this experiment, you remember I added to a fluid, I added a drop of blue food dye, and then I added a drop of yellow food dye. What I didn't tell you is in the mixture, in the fluid, it's a mixture of salt water and alcohol. Salt water and alcohol. Thank you there, Patriot. It is like oil and water, but in reverse. So let me explain what's going on here. We'll do this one more time. We'll do this experiment one more time. Let me mix this up first, and then we'll add a couple bottles. We'll do that experiment one more time, and I will explain how, you know, this separated into a blue layer and a yellow layer. So this went green. Let's just quick add a bunch of 1, 2, 3, 4, 5, 6 drops of hydrochloric acid. A couple more, make it red. And then we're going to turn off the stir speed. Can I create an aldehyde from an alcohol? I'm not much of a synthetic chemist. I mean, I could probably look it up and learn how to do it. I don't remember a whole lot, but yeah, I think it can be done. Well, we got to oxidize it, right? So a little potassium permanganate might get you there. Looks like Ukrainian chemistry, Rasmus. That's right. Okay, so let's do that other experiment one more time. What's an aldehyde? So here, let me draw it for you. So an aldehyde is going to be a chemical compound that's made of carbon, hydrogen, and oxygen. But specifically, here's an aldehyde. This is a 2-carbon aldehyde. There we go. 2-carbon aldehyde. An aldehyde is going to have a C double bond O on an end carbon. There's a whole bunch of different like carbon-containing molecules that we give names to depending upon different groups that we call functional groups on the molecule. D to T transitions are indeed beautiful and give rise to a lot of gorgeous colors in the D block elements for sure. Okay, so let's look over here. And I'm going to describe how this particular experiment works, where you can get this separation between blue and yellow. So what I'm going to do now is I'm going to get out a fresh bottle. And this particular fresh bottle contains a mixture. I didn't tell you this last time, but it contains a mixture of salt, water, and alcohol. So it contains a mixture, not of salt, water, and alcohol, This contains a mixture of water and alcohol. My apologies. Okay? Water and alcohol. Thank you there, Tunisia. So this contains water and alcohol, and to the water and alcohol, water and alcohol mix in all proportions, so this is well mixed. So to this mixture of water and alcohol, what's this? Thanks for using YouTube. May your day go well. We are here to tell you your live is creating a technical issue in your servers. Uh-oh. No, I doubt that. So we are going to put that user in timeout for 24 hours. Okay. So I think, folks, things are okay, I imagine. I imagine that's just somebody trying to, spam the comments. Thanks, administrator. I thought so. I blocked him. Okay, so remember, we have a mixture of, water and alcohol. And I thank you, folks, for letting me know that was fake. I'm going to go ahead and add a drop of blue food dye into this mixture of water and alcohol. And that's just beautiful to watch. It's neither, Katie. It's neither. Thank you, administrator. I appreciate that. So sugar is neither acidic nor is it basic. It's one of these compounds that are just neutral. Look at what's going on over here, by the way. I think I'm going to add a little bit of acid over here just for the heck of it, see what happens. Oh, I'll add another drop of base. 2 more. And then I'm going to chase it with a little bit of acid. There we go. Let's see what happens over there in time. Anyway, if we look back over here, this is always cool. In our mixture of water and alcohol, I have added some blue food dye. Now I'm going to add some yellow food dye, all right? Blue food dye, yellow food dye. Sam Finch dropping some chemistry in the chat. Thank you. So there's your drop of yellow food dye. Thanks, Patriot. Appreciate that. Appreciate that. All right, so now we've got our mixture of blue food dye, yellow food dye, alcohol, and water. And these will mix in all proportions. You'll be able to see this. I'm going to go ahead and mix this up. So this is my mixture of blue food dye, yellow food dye, alcohol, and water. When I mix that up, everything mixes together really well. And what we say on the molecular level, that the dyes, the blue food dye, and the water and the alcohol and the yellow food dye, they attract each other really well. It is rubbing alcohol, Katie, so I used half and half. All right? Why is the viscosity so high? Rubbing alcohol has a high viscosity. Okay, now, let's remember what we got here. We got our blue food dye, we got our yellow food dye, we got alcohol and water. Now, when I add the salt is sodium carbonate. What happens when I add the salt is the salt will dissolve into ions, and those ions are extremely strongly attracted to the water molecules. So you get an extremely strong attraction between water molecules and the ions in the salt. And when that happens, the attraction is so strong that the alcohol is no longer attracted to the water. You know, it's kind of like when you have some people and two people kind of fall in love and they love each other so much that they start dating each other exclusively and they push everyone else out. So what that means in terms of this is the salt and the water, in a sense, will start dating exclusively. The salt and the water will be so strongly attracted to one another that they will push the alcohol out. All right, so here we go. And then the other thing that'll be going on, so the water and the salt are really starting to get attracted to each other here. But the other thing that goes on is it turns out that the yellow dye, that's strong enough attracted to the salt water now that it'll remain in the water layer, which is on the bottom. And the blue dye, well, that's not going to be strongly enough attracted to the salt water that it actually gets pushed out and goes into the alcohol layer. So once I get all that salt dissolved by shaking this, we'll see it happen. You can already see it down here, right? You can see it going on, man. You can totally see it happening. But here we go. We have the mixture of salt, water, alcohol, blue food dye, and yellow food dye. Thanks, Administrator. Someone here from Bangladesh. Very cool. Thank you there, Katie. And look at that. The salt water is very strongly attracted to each other. It pushes the alcohol out, and it turns out that the blue dye dissolves better in the alcohol layer, and the yellow dye dissolves better in the salt water layer. Thank you there, Slow. Adiyaman from Turkey. Thank you there, Carol. Someone from Arizona, Patriot. I'm going to be heading to Arizona in a bit for a little bit of vacation. Check this out over here. We're seeing some cool color patterns over here. Someone in Germany. Hungarian, nice. Add a few drops of base over here. That was fun. That's a fun little experiment I like doing. Problem with that is you can only do it once. You know, this one you can do over and over again, which is nice. All right, let's back up the train here just a bit. Let's get some acid-base chemistry going on, shall we? Here we go. I'm going to turn this on. I'm guessing that there's an excess of base over here. We're going to find out, though. Let's see. Someone from Canada. Very nice. Very nice. And it looks like the acid and base over here were balanced. And actually maybe just a little bit basic. Just a bit basic. So our pH is 8 over here on the right. Our pH is acidic, or 3 over here on the left. Duncan, Arizona. How close is that to like Phoenix? Here we go. Let's add some drops in here. Cleveland, Ohio. We got some slow. I don't have litmus. This is universal indicator. Oh, nice. Sorry, every day I screwed up the colors that you were liking. 240 miles to the right of Phoenix. Got it. So you're closer to New Mexico, eh? I guess that's right. Hello, Dr. Rust. What's happening? Man, we got a lot of we got Ohio in the chat here today. A lot of that. A lot of Ohio here in the chat. A lot of Cleveland. Every day. All right, let's add some hydrochloric acid to these. Oh, nice. Very nice. 15 miles from the border. But it's going to be a ways from, what do they call it? 4 Points? Is that what they call that spot? Four Corners. I missed the mixture consisted of methanol and water. Milkman, the mixture consisted of isopropyl alcohol and water. So it was a 50-50 mixture of, about 250 mils of water, 250 mils of rubbing alcohol, which is 70% isopropyl. That's what I did, okay? And then I added 50 grams of sodium carbonate. Jamal, I buy them all over the place, usually at like hardware and grocery stores. What is crystal field theory, asks Kim Jong? That's going to be a theory that describes why transition metal elements tend to be colored. So we're going off into some theory here, folks. Just see how much of this sounds like gibberish to you, all right? If you had a chemistry class, you're going to know a little bit about what I'm talking about. So crystal field theory, that's a theory which we say that when elements in the D block of the periodic table, when they form compounds, their electrons in the d orbitals specifically, they are going to split depending upon how the various, we call them ligands, those are the things that are going to bind to the metal, how those various ligands approach the electrons in the metal. And as they approach the electrons, those d orbitals are going to split. And the difference in energy of those splittings will correspond to a particular energy. And then when light of that energy is absorbed, the electrons can then interact with those, the light can interact with those d orbitals. And, because specific energies of light have specific colors or wavelengths, as that light gets absorbed, that interaction of light with the compound is going to give a color to that particular compound. I think can I do in some future some dialysis? So you're meaning, I do like neptunium. I'm going back through and looking at some of these comments. Can I do in the future some dialysis? So you mean like using dialysis experiments, dialysis tubing? RBMK, please give me the definition of those letters in that abbreviation. I doubt it. Kim Jong, I think copper 1 is going to be orange in color in my experience, but you may be talking about something different than I. In my experience, copper 1 is an orange color, generally speaking. Slows like in some uranium. Milkman, it's isopropyl alcohol, 70% by volume. Oh yeah, Katie, that's a good idea. I'd have to buy some of those. I'd have to buy some of that tubing. That'd be interesting. You got it, Milkman. Kim Jong, I kind of feel like you're testing me out there to make sure I know what I'm talking about. Well, you can stump me for sure. You keep asking me chemistry questions. I mean, I do have a PhD in chemistry, but that doesn't mean I know everything about it. That's for sure. I'm a physical chemist, which means, and I'm general. I'm a general chemist, which means I know a lot. United Kingdom, the golden penny experiment. Let me tell you about the golden penny experiment. So that's the one where, you take some zinc in a solution, a strong solution, zinc metal in a strong solution of sodium hydroxide, and then you add some pennies to it, and the zinc will plate, copper coins, and the zinc will plate out on the copper coins, give it a nice shiny coat. It's really beautiful. Oh, thanks, Kim Jong. Hey, thanks there, Peter. Thanks for joining in. Anyway, so if you heat that silver-coated penny, it's not silver-coated, it's zinc-coated, but if you heat it, it'll give it a gold color. It'll look like it's brass. Well, it is brass. It'll look golden. Well, there's a simpler way to do that, United Kingdom. There's a simpler way to do it, United Kingdom. You're not going to believe this. Get a really, really shiny penny to begin with, copper coin, okay? Make sure it's, quite new. And then what you do is you're going to get your hot plate, and you're going to set your hot plate at around 250 Celsius. You might have to play with that a little bit. You might go a little lower, but I tend to get the best results when I set it light water graphite reactor. We'll talk about that in a second, administrator. So get your hot plate set at 250 Celsius, maybe a little less. Then you put that shiny penny on that hot plate and just wait. Wait over the course of a couple minutes. You're not going to believe your eyes. That penny will first start, I'm going to try to remember this. I think it first looks like it's got a violet color. It might be orange at first. I think it's orange at first. And then it goes violet. And then after violet, it'll look like it turns silver. And then finally, it'll look like it turned golden. And what's going on there is at that high temperature, oxygen from the atmosphere reacts with the copper penny, and it forms a coating, a surface coating of copper oxide. And as the thickness of the copper oxide layer changes, the color changes. Look this up. I think it's, what the heck is the thing called? Just look up Rainbow Penny Demonstration, Journal of Chemical Education. Hey, have a good day, Patriot. Thanks for hanging out. Appreciate it. Hello there, Ionis. Yeah, it's remarkable. And then, United Kingdom, once you have that golden penny, you can actually do this at any point in the color. If you dip it in a solution of vinegar and salt, the copper oxide coating will dissolve, and you'll go back to the original shiny copper. It's a really cool experiment. And you don't have to use, you have to use a caustic sodium hydroxide. So Tunisia doesn't have a GED, but they're working on it, and they're not giving up. Awesome. Awesome. Keep fighting. All right, I'm adding some sodium hydroxide over here on the left and the right. Beautiful stuff. Which molecule is used to explain the concept of hybridization? Do you mean originally? Or just, you can use all sorts of molecules to describe the concept of hybridization. All sorts of stuff. Well, you can use water. Light water graphite reactor. Administrator, thanks for being patient with me, and I apologize. I've not heard of what you're talking about. So, please, Adiant, I'm guessing H2 plus, but that's probably not going to be hybridization, right? H2 plus, it's not like you're going to get two s orbitals hybridizing. I mean, I guess they do, right? The two s orbitals are going to combine, and they're going to make a 1 sigma bonding orbital. So that's going to be my guess. And you can, it's methane. So methane would be the first molecule so that's the first one in the literature, Adiant, that folks use to describe hybridization. Can I dissolve sodium chloride in both? Got it, Administrator. Actually, that is happening, Chris Yang. I've already got sodium hydroxide dissolved in this. You say, wait a minute, I'm just adding drops of hydrochloric acid or sodium hydroxide. But you know that sodium hydroxide and hydrochloric acid, when they react, they form sodium chloride, and that sodium chloride is indeed dissolved in here. So when this is neutral, which it is now at a pH of 7, we've got salt water. So I've already got the salt in there. It does look like a colorful hurricane for sure. Indeed it does. Let's add some base over here on the left. Watch what happens to that pH. So long, Administrator. We'll see you next week. Got a little rainbow action going on there. That was beautiful. What is hydrogen chloride? That is hydrochloric acid, United Kingdom. So HCl, that's hydrochloric acid. So Timeless wants to know what's going on. Sure, I'll back up here, Timeless. So it's really simple idea what's happening here. In both of these flasks is some water, and to the water I've added universal indicator. Universal indicator is just a pH indicator, and pH just tells you how acidic or basic something is. So just to repeat that one more time, since you're new, in both of these flasks is some universal indicator. Universal indicator is also known as rainbow indicator, and it will display these colors at different pH values, which tells you how acidic or basic something is. So we look, both these flasks are red, or maybe this one's a little reddish orange. And so what that tells me is, welcome back, Slow. Hello, Eddie. What that tells me is the pH of this flask over here is 3, and it's quite acidic. The pH over here is maybe a little bit higher, maybe pH 3 or 4. It's also acidic. Watch what happens when I start to add base to both of these flasks. Base or alkali. So in we go. I use the term base and alkali synonymously. I'm adding base, and you can see that red color over here is getting shifted to a yellow. Thank you there, Tunisia. Let's add a little more base over here on the right. A little more base over here on the left. The acid that's present and the base that I've added are reacting with each other, and they neutralize each other. Acids lose protons slow. So this was like a pH 4 or 5. And now it's a pH of 6 after I added base. So what happened was the base and the acid, they neutralize each other. So when I add base, to acid, it's going to get neutral, like I've seen over here. Hello, Henry. All right, we're going to start adding a few more drops of base to see what happens when we get an excess of base. Henry, you're going to get blocked. There's your warning. So I've added a bit of sodium hydroxide to both. See you, Henry. All right. So there's an excess of sodium hydroxide over here. That's why we got the nice violet color. I'm not messing with selenium, Peter. That stuff stinks, man. I'm not messing with selenium compounds. Not happening. What does that mean? What does Discord mod vibes mean? I don't understand. Does that mean I blocked them too quick? Okay, so the base made the color strong, made the pH. So Tunisia, what happened is when I added the base, the compounds in the dyes reacted with the base, and that caused the color shift. I'm now going to start adding acid. I mean, come on, man, right? We don't need that kind of crap, right? We're just trying to have a good time. I don't need that. I don't need it. I'm too old for it. There we go. You can see as I've added acid to the basic solution, this got neutralized, right? It went back to green. This one went all the way down to maybe a pH 6 or so from the acid that I've added. Thanks, there, Slow. Mork, what do you mean if you're going to make your head explode? What are you talking about? Timeless. I am a physical chemist, which means I study the physics of chemistry. So I know some physics and I know some chemistry. Yes, Adiant. One way you can think about acids is that they donate protons. Peter, I do not. And if I did, I wouldn't mess with it because those compounds stink. Oh, if you bit into a bar of sodium, how big a bar are we talking? I wouldn't recommend it. I wouldn't recommend it, Mork. What do you mean, what about base? I don't understand there. I hear you, Mork. I see you, Mork. Adding a little bit of base to both flasks. What's an advice I'd give to my younger self? Well, I don't know, man. Oh, man, what would I say to my younger self? Acids donate protons. So what advice would I give to my younger self? Man, what a great question. I don't know. I really don't. Would you die if you were to drink it, Eddie? No, probably not, but it would ruin your afternoon. Because one of the dyes in here is a laxative, so, you know. All right, let's see. There we go. Let's add a little bit of acid to both flasks. Have I ever had chemistry incident like some stuff you don't want to get spilled? Yeah, I have. I've spilled, all sorts of acids. So when you add the base, the pH is high. When you add the acid, the pH is low. You got it. All right, everybody drop it in the chat. United Kingdom has asked the question. I want to know, what's your favorite transition metal? What is your favorite transition metal? What indicators am I using, Slow? I'm using a mixture of indicators that we know as universal indicator. I like that, Zero. Come on now, or Zizo. I'd advise him to explore more, be curious, and not be afraid of failure, because that's how you learn. Love it, man. I think that's great advice. Boom, boom, boom. A little bit of base to both solutions there. Are we running out of... Yeah, I'm starting to run out of my hydrochloric acid. Tell about the first thing that made you love chemistry. The first thing that made me love chemistry. I was a sophomore in high school. Give us the advice. Come on, Slow. We're all nerds here. Come on, this is embrace the nerd chip. We are all nerds here. Buy Bitcoin. So, first thing that made me love chemistry, I was taking general chemistry 2 at the university. And, I thought I was going to be like a biologist. And I had this chemistry teacher. I still keep in touch with them today. And they were up at the front of the room and they did this experiment. It was some kind of color change, like colorless to pink. And, man, I was blown away. It was here I am, 20-something years old. It's the first time in my life I saw a live chemistry experiment. Have I ever heard of Technetium? Come on, United Kingdom. Come on now. Of course I have. And when I saw the experiment, I was blown away, man. I was like, this is the coolest thing I've ever seen. And I was hooked. I was immediately hooked. And I changed my major to chemistry and, never looked back. All right, what's everyone's favorite food? Cole, I'd do it in a heartbeat if he contacted me. He'd have to contact me, though. I don't think that's going to happen. I'm too small potatoes. So my favorite food is going to be Cliff Bars. I have, NYC. Of course I have. Here we go. Let's add a little more acid to both. I don't have any of that, Bob. Don't have any of that. Adding a little more acid to both sides. We got some cheeseburger. We got some steak, fries, and Diet Coke. Thank you there, NYC. I appreciate it. Appreciate it very much. I love Coca-Cola. Oh, man, that is my guilty pleasure for sure. What do we got? A little more acid. Adion, I've taken a number of organic chemistry courses, but that was a long time ago. So my organic, if you start getting deep into organic chemistry, I'm not the person to ask. Definitely not. But, I know my functional groups and I know some of the reactions that they undergo and, Thank you there, Arden. Let me know which one you like the best. Come on, that was some beautiful stuff over here we got there. Which video have you seen that you like the best? Cesium. So, United Kingdom, you've played with cesium, huh? I have only, on the alkali metals, the lowest I've gone on that column is rubidium. Why is that, Tunisia? Why should I stop drinking Coca-Cola? Let me know. Thank you there, Simon. Anyone know why I should stop drinking Coca-Cola? So you've messed with cesium, huh, United Kingdom? The science of water, huh? Thank you there. All right, what we're going to do, let me get this one over here. Let me get this nice and red over here on the right. Thank you there. Oh, the science of water. Thanks there, Arden. Was that the ice one or was that the one where I did heavy water? Hey, Grandpa, what's going on? I don't know. They haven't answered me. They haven't answered me yet. Why I should not drink phosphoric acid. Why I shouldn't drink phosphoric acid. Why I shouldn't drink Coca-Cola. All right, I'm going to turn this off over here. And we've got the pH nice and low. We got it down to... Because they say the formula for that stuff is bad, like you got a lot of stuff in there. I don't exactly know, but here it's bad. Got it. We got pH 3 over here. pH 3. And now I'm going to add some base. And as the base neutralizes the acid, we should see some other colors, right? And if I add enough base, well, the base that doesn't react, that should look violet. Yeah, I think I've heard of that, Tunisia. Like, only 1 or 3 people know the formula for Coca-Cola. Here we go. Let's add some base over here on the right. I've add 5 drops. We're going to kind of see what happens over there I'm going to add 6, as the reactions proceed. Gotcha. Yeah, you might be thinking of the phosphoric acid that's in Coca-Cola. Nice. You got to add more acid on the right. I used to think, oh boy, they're coming through pretty quick here. I used to think magnesium and manganese were the same. Sure. Coca-Cola myth isn't true, says somebody. Create the football team colors, says Bob. Bob, I want you to go check out the most recent short that I made. Let me know what you think of it, all right? And I will create those two colors. I mean, we already got the Eagles over here, right? So let's go over here, and we're going to make Kansas City Chiefs over here on the right. Here we go. We got to make the Kansas City Chiefs color, so we're going to add a bunch of acid over here to get the pH low, to get a nice red color. I'm not Canadian. No, I am not Canadian. I'm United States. I live in the United States. I have all my life. What football team is that? So we're talking about American football. So here we go. We got the Kansas City Chiefs. We got the Philadelphia Eagles. So, hey, you know, if you know what's going on with the Super Bowl here in America, United States of America today, then, yeah, why don't you go ahead and drop a green heart in the chat. If you want the Eagles to win, drop a red heart in the chat. If you want the Kansas City Chiefs to win. Bob, I take it you watched the video. Red heart for Kansas City and green heart for Philadelphia Eagles. Let's see what we get. There's the two colors. I'm going to change them up now. A little bit of base over here on the right. Keep dropping them in. Keep dropping them in. We got one vote for the Eagles. Eagles are winning 1-0. Oh, man, Eddie's got to vote for the Eagles. I'm sorry, buddy. I'm only counting one of those. That's all right, Peter. Don't sweat it. Don't sweat it. I recognize not that. So we got 2-0 Eagles. 2-0 for the Eagles. Grandpa is... What is that, Mr.? Oh, the Vikings. Come on, Mr. Slappy. So we got a 2-1 score. Grandpa, you already voted. Adia, oh, it's tied up at 2-2. We are tied at 2-2. You only get one vote. All right, Free says the Chief. It's 3-2. Bob, did you already vote? I got to go back and look. Nope. All right, it's tied up at 3. What are my favorite actinides? Let's see. Oh, I'm going to start losing track of what I have to keep remembering here. Actinides. You know what? I'm pretty close there, Cole. I'm pretty close. Cole, I'm going to try it here. Here we go. I'm going to add another drop of acid over here, see if we can get this to yellow. I think I got you, bud. Come on, Cole. I think I got your Vikings right there. Huh? I'm going to add just a little bit more base over here, see if we can get that a little bit more violet. I think I got you. I think I got you. Well, according to this chat, it's going to be a tie game. Thorium to lawrencium. I'm going to say probably plutonium. United Kingdom would be, I'm guessing. Oh, we got an extra one in for the Chief. Name any 3 strong acids in 3 seconds. Hydrochloric, nitric, and perchloric. Actinium, thorium, proactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, mendelevium, nobelium, lawrencium. I think I probably missed one. Yeah, I think that's it. I think, according to this chat, it's Chiefs 4 and Eagles 3. If you want to see my prediction, go check out the recent live that I put out. I put out a new new short. I put out a new short every Saturday, every weekend. A new one comes out. Name 5 strong base. Lithium hydroxide, sodium hydroxide, potassium hydroxide, calcium hydroxide, and strontium hydroxide. Adyan is testing my knowledge. He's making sure that I'm actually a chemist over here. They don't believe me. What's the scariest compound chemical I've ever worked with? Probably sulfuric acid. No, I also did, thank you there, Tunisia. I've also done piranha solution. That was nasty, man. I used some of that stuff. Well, you can check. I put a scrub daddy in it for my channel. It's kind of fun. It's kind of fun. Oh, man. I'm going to have to refill my container, huh? Look at that. Not much left. That's all the acid I got left. Let's do a refill, huh? I don't know if I got time for it. Well, I got a little left. We can keep going. Thank you there, Tunisia. It is a little calming, like that purple and that green. Kind of nice. Piranha solution is great. You made it in your home lab. Yeah, HF or fumin. I've never used fumin nitric. Isn't hydrochloric, I think you're asking, acid the one that looks like salt? Hydrochloric acid is HCl. HCl, a hydrogen attached to a chlorine. Sodium chloride is NaCl. Slow like anything else. Lots of practice. That's it, right? Like anything else in life, you want to get good at something, you got to work at it. Put in the time. I'm in my 50s, Adiant. So long, Bob. Thanks for hanging out. Hope you enjoy the game. Ooh, that's some beautiful action going on over there. Beautiful action. But yeah, I'm going to need... Oh, we're out of acid. We are out of acid. Yeah, it's your best bet. That is your best bet. Got a good squirt of acid over there on the right. HL is often used as an abbreviation for medication to indicate a hydrochloride salt. Indeed, Peter. That's right. Indeed. All right. That's it. I'm going to have to flip the camera around here. I do not, Adiant. No, Cole, heck no. I just do YouTube. I just do YouTube as a hobby. Yeah, in a little bit here, slow. We're going to flip the camera around. We'll talk to you for about 5 minutes, maybe 10 minutes, and then we're going to call it a day, all right? So that's a fair warning, just so you know what's coming here. You're going to see my ugly mug. If that's not something you want to see, now's the time to get out of the chat for sure. Woo! All right, let's flip her around. Let's talk to folks. Thanks, every day. I appreciate that. They got to stop making an ammonia-based toilet cleaners because it's way too... Yeah, how about it? How about it? Let's get my glove off. Oh. Thanks, Slow. Appreciate it. Ooh, that's not good, Peter. That is not good. That'd be nice, Adiant. I have a friend who's from India. I worked with him in graduate school. Thanks, Kim Jong. Appreciate it. I'm feeling old today. That I am. I played some pickleball earlier. I'm a little sore. Oh, you're a dentist. That's cool, Adiaman. I'm actually working on an article on, an educational article on the chemistry of teeth. Hydroxyapatite. Is chlorine bad for, and why do we put it in our pools? So chlorine, I suppose too much of it is bad for you, but a little bit not so bad, and it's really bad for all those microorganisms that would, cause you problems when you go swimming and, cause growth in your pool that you don't want. I don't know what that means, Pan Wizard. Can I try to freeze dry snow? I don't know what you mean by dry snow. Do you mean that? So long, Eddie. Do you mean that polymer stuff that they use to make fake snow? What is that, sodium polyacrylate? Is that what you're talking about as dry snow? That's a neat idea every day. That's a neat idea, but I'm not sure what you mean. It is not, Kim Jong. That's too low. Real snow. Interesting. Well, it's already frozen, bud. Right? Right? I mean, if it's already it's snow, it's ice, it's already frozen. So every day, I apologize, I don't understand the question. So you're asking me, is there a way to freeze dry, real snow? And then I asked you, what do you meant by that? And you said real snow. So it's already frozen. You're trying to catch me. Come on, man. Thanks there, Slow. Appreciate it. It'd still be, you still got to put in the work. It's going okay, Christ. It's going okay. How about yours? I'm a little sore. I played some pickleball earlier, and man, I moved a little too much. I do too, Dark. Yeah, Grandpa, that's right. The chemical reaction between the compounds they put in the pool and the amines that we release, in urine, that's the stuff that gives it the odor. Sodium polyacrylate loses size in the freezer or fridge as it loses water. Oh, that's cool, Peter. That's cool. Is the universe mostly cold or hot? Need a little more information there, Syapster, to answer that question. Oh, please do let me know, Chris. I appreciate that. Thank you, Chris, for the correction. Thank you there, every day. Hey, thank you there, Maya. Appreciate that. Urea and HCl. Uh-oh. The most accurate atomic model as Akshat. Forgive me if I said that wrong. Next live will be next weekend. Chris, good. So I would say the relativistic treatment of the hydrogen atom done by Dirac. I know they've improved upon it since then. I think they took into account virtual particles that made an additional correction. Thank you there, Tunisia. Do I play games, Chris? I just got done playing pickleball today. I mean, there are vast empty spaces and many stars. That's right, Siapser. So I would say there's regions of the universe that are extremely low in temperature. And I would say there's regions of the universe that are extremely high in temperature. And I would say on balance, it's more low temperature than high temperature. But I don't know. I'm not a cosmologist. Chris, I do not play. I do not play video games. Yeah. I used to, but it just took up too much time. You get to my age, time starts meaning a little more than it did when I was younger. But you know what? I watch a bunch of American football, and that's a waste of time too. So, I think taking time to just goof off is important too. So, I have not, Chris. So long, Adi Amin. Thanks for hanging in there with us today. Appreciate that. I am Syapser. Cosmic background radiation makes the space hotter. So the Kobe Aono, I apologize if I'm not saying your name right. In my understanding, that's like 2.7 Kelvin. So that's, that's not a very high temperature. The Kobe radiation, if you fit the black body curve to that, that comes out at like 2.7 Kelvin. And my understanding is that's not real warm, right? That's cold enough at this pressure to liquefy helium. I'm a chemistry professor, Akshat. So tell me what you mean, Aono. What's my favorite reaction? Coke and Mentos, baby. How about you, Kim Jong? What's your favorite? I don't know. Well, I used to be a lot fitter there, Stephen. Oh, your chemistry is really bad, especially physical. What should I do? Any tips? Yep, sir. Keep hanging in there. Keep showing up. Keep doing the problems. And you're going to be better off. That's what I'm thinking, Peter, right? We're like 2.7 Kelvin, man. We got a message held for review. And we're going to hide that one. Steven, I'm going to block you if you put stuff like that in the chat, all right? Just letting you know, buddy. Just letting you know. Dante, same way. Don't sweat it, man. I mean, I get it. Don't sweat it. I just wasn't talking to you, Steve Play. Here we go. Some basic concepts. Atomic structure. Period. Oh, this is on the Indian syllabus. Yeah, it's very similar to what we teach here in. See you, Dante. So long. Does the pressure in a bottle increase? It does not, Grandpa. It does not. The pressure in a bottle does not increase when it's shaken up. You can check it out online. There's, you can Google this. And there's an actual study that's done. Hopefully you'll get a hold of the study so you can see the data. Moles and molar mass. So long, Han. So, Aono. Here's the deal. Apologize, I'm not sure from the name, if anyway. Do you know what a dozen is? Oh, thanks, Kim Jong. That is a freaking cool video. I agree. Man, the gallon stand reaction with metal ions are crazy. Thanks, Sir Hans. I appreciate it. Okay, so, I don't know. You know what a dozen is, right? Okay, so, if you know what a dozen is, you know the word dozen means a number. When I say dozen, you think 12. And with moles, you want to do the same thing. So when you hear the word moles, you should think of a number. It's a stinking huge number. It's a really big number. It's much bigger than 12. Much, much, much bigger than 12. All right? It's, as you know, it's 6.02 times 10 to the 23rd. So it's basically 6 times 10, 23 times. It's huge. It's just a huge number. And if you have that many of something, if I have 6 times 10 to the 23, so long, Hans, 6 times 10 to the 23 of something, then I have a mole of those things. Just like if I got 12 eggs, I got a dozen eggs. If I have 6 times 10 to the 23rd eggs, I got a mole of eggs. Okay. So, how does this relate to molar mass? Well, here's the way I tell my students. You got your periodic table, and you got the number at the top, like for carbon, the number at the top is 6. We're not going to worry about that number 6 when we're talking about moles. We're going to look at the number below the element, the C. That number is 12.011. And what's cool about this, it's so awesome. That number, that 12.011, it's not the whole number. It's the one with the decimal. What we do is we say, you know what? If I have 12.011 grams of carbon, remarkably, I have a mole of carbon atoms. So it's like every element on the periodic table is screaming at you, that bottom number. Hey, like hydrogen is 1.008. If you got 1.008 grams of hydrogen, you got 1 mole of hydrogen. For helium, if you got 4.0, I can't remember, it's like 4.01, I think, 4.01 grams of helium, you got a mole of helium. That's the basic idea. If the pressure doesn't increase, then why does it blow up when crushed and shaken? So, Grandpa, I'm not sure what you mean, but if you're crushing the bottle, then you're ruining the integrity of the bottle, and that might be, if you ruin the integrity, these things are sealed under 4 or 5 atmospheres of pressure. So if you try to crush that bottle a little bit and you ruin the integrity of the bottle, then that gas pressure, which remains at like 4 atmospheres, can be able to push that out. So y'all are wanting to talk about the mole concept. Is that what I'm hearing? Yeah. I hope that helped, Aono. I mean, if I'm going to talk about moles, I should get the periodic table out. Maybe I'll do that next time, man. Y'all come back. We'll talk about moles a little more. I think I'm going to head out, though. It's time for me to spend some time with my wife. I've been looking at a screen too long. It's been going on a little over an hour, and that's usually all I can handle. So I appreciate y'all hanging out with me today. I don't seem to have quite the energy today that I normally do. I think I'm just a little bit tired. So, thanks for hanging in there with me, and hope you had a good time watching some of the experiments. Oshkot, thanks for the sub. I appreciate that a lot. You got it, Aono. That's exactly right. Like a dozen cars has an enormous amount of weight. A dozen cars is going to have more weight than a dozen people. Same thing with atoms. Well, yeah, of course, Grandpa. If you make a dent in the plastic, then you've ruined some of the integrity. And these bottles, I've done experiments with them, Grandpa. These bottles will, depending on the size and all this stuff, but roughly speaking, if you exceed 10 atmospheres of pressure in the bottle, it'll fail. It'll burst. And they only seal them under 4 atmospheres, so they're fine. But you mess with the integrity of that bottle, you start to mess around with it. Okay, now you've made it so that it no longer can handle the 10 atmosphere pressure. Maybe it can only handle 3. And in that case, the bottle's going to fail. I'll come back next weekend. Hey, Stuart, next weekend. Oshkot, xenon's going to make extra bonds, even though it's a noble gas, because it's a larger atom. And as atoms get larger, even though, noble gases have a full stable shell, if that atom's electronegative enough, it can pull electrons toward itself enough, like fluorine, very electronegative atom. You start mixing xenon and fluorine together, and now you got something that might be able to make a bond. Yeah, I do regular, but it's like Friday, Saturday, or Sunday. One of those days is usually when I go. Hey, Messy, thanks. Slow, I'm a little slow today. I'm not feeling so good. So, all right, we'll see you next time, folks. Thanks for